Hello everyone. In this video we are going to see T flip-flop. So basically all the types of flip-flops we have previously discussed, but this is a special type of flip-flop which is toggle flip-flop. Okay, so T stands for here toggle. Alright, so what is meant by this and the logic diagram for this one and as well as the block diagram we will be seeing. Alright, so we'll see also the functionality of this one. Okay, so first I will start with the definition. The T flip-flop is also known as toggle flip-flop. This is mainly developed to avoid the occurrence of intermediate state in SR flip-flop. So while studying SR flip-flop, we have seen that when both the inputs are high, there is a intermediate state, that is, we are not sure whether it is 0 or 1. So at that time, to avoid that intermediate state, we have developed a T flip-flop. So basically T flip-flop is a modified version of SR flip-flop. Here we will be giving the same input to the both the gates here. Okay, so we will be shorting one and we will be taking through NOT gate. So all those things we will be seeing in the diagram itself. Alright, so this is basically to avoid intermediate state. So that's the first point which you should remember. Alright, so next one, here only one input is provided to the flip-flop called trigger input or toggle input T. The flip-flop toggles the output. So as I said earlier, here only one input will be given and that is shorted to give for second gate also it is shorted and given. Okay, so that means that input is also called as trigger input or toggle input. So output will be toggling from 0 to 1, 1 to 0. So like that. From this fact itself, the name came toggle flip-flop. Alright, so how to design this one? See how I can design this toggle flip-flop. Alright, so the design contains how the T flip-flop can be designed with the help of JK flip-flop. So we can use JK flip-flop to design this one. Okay, so here the J and K inputs are connected together and provided with same input. Okay, so it is also called as single input JK flip-flop. So we can construct this with the help of SR flip-flop, or else we can use JK flip-flop as well. So in this case they have used JK flip-flop. So JK flip-flop, the same input is given and that's why it is also called as single input JK flip-flop. Okay, so how it looks? Okay, the symbol diagram we will see now. So this is the symbol diagram for T flip-flop, where we will be having a single input T. Then this is the clock which is used for a synchronization, and then this is Q and this is the Q bar. So these are the two outputs. So first one is non-inverted and this is the inverted output. So they will be opposite to each other. Alright, so that's the diagram which shows the T flip-flop. Then logic diagram, actual circuitry, how it looks. So this is the logic diagram, guys. So you can see here. So this is the JK flip-flop itself. So AND gate is there. For this we have connected a NOR gate, and you can see here. So this is the NOR, and Q is there, Q bar is there. Feedback is taken from Q and given to the first AND gate, and this is the clock which is provided for both the AND gates here. And T input, single input has been taken and it is shorted here to give it to the second gate also. So you can see the diagram. So you can see S and R. So this forms the SR. When you take the feedback, it becomes JK, and when you short the input, it becomes T flip-flop. So it is as simple as that. So if you know SR diagram, then you can construct JK, then you can construct T. You can do almost for basic structure looks like this. So this is the basic structure which will be present. So if you connect these AND gates, then it will become JK. So you know all the differences already were discussed earlier. Okay, so how the truth table looks like? So truth table is something like this, and you can see here. This is T, this is Q previous, Q previous bar, then Q next bar. So this is the previous state and this is the second state which it will be entering. So when T is 0, Q previous will be 0 and the Q bar will be, of course, if it is 0 then it will be 1, and Q next will be, you can see 0 and 1. Okay, so if it is 0 then the previous state and the next state will be same, 0 1 0 1. So that's the ultimate meaning which I want to tell. Then if toggle is again 0, then if these conditions are 1 0, then output again it will be same because toggle is 0, so it will not change the output. But when toggle becomes 1, at that time assume that these are 0 and 1. at that time you can see the output will be the opposite of input. So Q previous is 0, Q next is 1. Q bar previous is 1, Q bar next is 0. So you can see 0, 1 is converted to 1, 0. So this is why it is called as toggle flip-flop. It is toggling the input. Input is changing to its opposite polarity here. And for next condition you can see 1 again it is changed here. So 1, 0, and it will be of course converted to 0, 1. So this is how it will be working. So I hope you like this video, and if you are an electronics lover then you can subscribe this channel because we will be uploading lot of these stuffs interesting videos daily. So thank you guys, thanks for watching this one. See you in the next one.